learning. We're here on this screen for at least the next 3 weeks, if not longer. Please God, not longer. But anyway, for the next 3 weeks, we will be meeting here quite regularly in relation to trying to get forward with some of our material. I'm going to go straight into the next chapter. The next chapter is based on what we call functions, and functions are something that you've been doing since day one. You go back to your time you learned how to add, okay? 1 plus 1 equals 2. 2 plus 4 equals 6. 7 plus 3 equals 10. Okay, that basic sentence sums up everything that you need to know about functions in terms of what they are, not in terms of their mathematics, because we have to go through that in quite a bit of detail throughout this chapter. But just take the 7 plus 3 equals 10. 7 is our starting point. Okay, plus 3 is how we change the 7, and then 10 is what happens after the 7 has been changed. Now, to put mathematical language on that, 7 is our input, plus 3 is our operation, and equals 10 is our output. So there's kind of a bit of an image there about putting something into a machine and getting something out of the machine. Okay, it's a very crude image for functions, but it's an image nonetheless that kind of helps us to understand what's going on. To put more mathematical language on it, we talk about a domain. Okay, and a domain is nothing more than a set of values that will all be shoved into this particular machine, this function. The function will then take each number and do the same operation to each number, whilst at the same time then it'll spit out a set of results for each number that you input. So the group of terms we input is what we generally call the domain. The function is what does the operation to change the domain values into what they're going to become when they're spat out of the machine. And all the numbers then that are given out as a result are your set of what we would call range numbers. Okay, more about those later on. Just for a moment, let's carry on. A function, as you can see from this slide here, is a rule that maps an input to a unique output. So let's just take that whole thing of 7 plus 3 equals 10. And I just want you to keep that in your head. Okay, what is this actually saying? This is saying that if I start at 7 as my input, and I then add 3, which will be my function, or my action, I will then get plus 10 as my output. Okay, that's the crude image. In mathematics, we would say 7 is my domain value, plus 3 is the function. That really doesn't change, or the operation we do on plus 7, and 10 is then the range output. So what does the function actually do? The function does nothing else than map, and that's a key word, map an input to unique output. So in this example here, 7 is mapped to 10 through the function plus 3. Okay, now that's just a crude introduction to what we're going to do in this section. So keep that in your head as we go along. Okay, as I said to you, the crude image is a machine, and I suppose when you did functions in junior cert, it was probably the image that was given to you, something perhaps something like this. So you had your input values, in this case here 2, 3 and 5. You then multiplied it by 2 and added on 10. Now I want you to notice something here that's important. We can't multiply by 2 and add 10 in one go. No matter how good you are, when you're doing mathematics, you do mathematics step by step. Okay, now that will bring us on later on to what we call composite functions, where an overall function is nothing more than a set of steps. Okay, and this gives it a very good idea as to how they work out. So in this case here, we have 2x plus 10. So if I was to put this in algebraic form, the function itself would be 2x plus 10. The x, or whatever other variable they decide to use in the function, is the place where you put in your input. So in this case here, that is where each one of these values 2, 3 and 5 are going to go. So when I put 2 into this function, what happens? 2 times 2 becomes 4, plus 10 becomes 14. And I already have a couple of these things done for you. So 2 is mapped to 14, 3 is mapped to 16, and 5 is mapped to 20. Let's just take some of that off there, if I can. If I can, erase. I can't remember how to do this, it's funny. Can't remember how to do this at all. Erase, there we are, hooray, I found it. Anyway, that's it. So, let's just take that as we have it. Pen. So 2 is mapped to 14. Why? Because 2 times 2 is 4 and 4 plus 10 is 14. Do you see how the overall function of what we would call 2x plus 10 is broken into two smaller steps. 3 is mapped to 16. Why? Because 3 times 2 is 6, and 6 plus 10 is 16. And finally, 5 is mapped to 20, because 5 times 2 is 10, and 10 plus 10 is 20. So keep that in your head as we go forward. Okay, there's your function. Now, a couple of words I've used already, which I need to go through with you again, and you need to carry in your head as we go into this particular chapter. One is your input. Okay, these are the numbers that you are about to place into the function, and the function is going to do something to them. Okay, when the function does something to them, it's going to spit something else out the other side. But the numbers that go in are called your input. And when you gather all your inputs together, you get what's called a domain. So therefore, a domain is a set. And that's key. All right. So for example, you might have a set of 1, 2, 3, 4, which means that 1, 2, 3, and 4 are about to be placed into this function machine. Okay. You then have, obviously, your output. It's what happens after the function has done its job. And the result that comes out as a result of the function doing what it's supposed to do to the input, that is what we call the output. When we gather all the outputs together, we get what's called the range. So let's just say, for example, that in this case the function was plus 2. So when you put these in, you're going to add 2 to each one, which means you'd get out 3 plus, or 3, 4, 5, and 6. So 1 plus 2 is 3, 2 plus 2 is 4, etc. Okay, and again, a range is a set of values. Now, there's one other word that I need to introduce at this stage. A lot of people get confused with, and it's called the codomain. All right, and the codomain is nothing more than the set of all possible outputs. So therefore, you might have a situation where, for example, take your menu. Okay, you walk into a restaurant and you pick up a menu, and from that menu you want to select a certain plate or a certain starter or a certain dessert. Okay, all the desserts are available to you, but you only select one. And likewise, all the main courses are available to you, but you select one. All the starters are available to you, but you only select one. So therefore, the menu, the item from which all your possible food can come from, that's your codomain. But what you actually select as your, I suppose, your own menu, your own personal gathering of food, that would be what we would call your range. Okay, so I want you to keep that idea in your head. The menu helps us with the codomain and the range. So all of the menu is the codomain because they're all possible for selection. They're all available for selection, but you can only select one starter, one main course, one dessert. And whatever you select and you put in front of you, that is going to be your range. So therefore, your range comes from your codomain. It can be smaller than your codomain, but it can also be equal to your codomain. So just keep that in mind as we go on. Okay, so let's get into the whole idea of what functions are. Now take this picture here. This again sums up exactly what I said to you a few moments ago. A function is any operation that takes values in, namely here x, and spits out, for want of a better word, or transforms them into some type of output. Now in this case here, it's very easy to see what's happening. 1 goes into the machine as an input, 5 comes out. 2 goes in, 6 comes out, and so on. Okay, so what I would say here is that 1, 2, 3, 4, and 5 are my domain values. Now, something happens to those values on their way across to what we would call the range side. And that thing that happens in here is called your function. All right, now, lovely. There's one thing I want to remind you of here. It's all alphabetical. D to F to R. Function, domain to function to range. So again, when you're worrying about the three words and what way they operate together, they always operate in alphabetical order. Domain goes into the function has an operation that it does on each one of your input values, and it spits out a set of outputs which we call the range. So domain to function to range. And in this case here, if I was to ask you, what are your set of domain values? Well, have a look. What are your set of domain values? In this case, your domain values, curly brackets, 1, 2, 3, 4, and 5. What are your range values? Well, your range values are 5, 6, 7, 8, and 9. Now think about that for a moment. Look at 8. Not part of my range because it wasn't selected. So therefore 5, 6, 7, 9, the numbers to which the arrows actually go to, they are my range. But then what's 5, 6, 7, 8 and 9? And the answer is, that's my codomain. Okay, that's my codomain, and that's what I need you to remember. So 1, 2, 3, 4, 5, my domain values. 5, 6, 7, 9, my actual outputs, my range. Okay, and finally then 5, 6, 7, 8 and 9, all the possible outputs are what I call my codomain. Okay, let's just get rid of that text there. So I think there's some text coming behind this one. Okay. No, not that one there. Okay, so as we said already, another set over here, or two sets. We've got a set of movies, which again would be my domain. And then over here, you'll notice straight away, I have a codomain. And the reason why I call it a codomain is because it contains all possible values. Okay, now take my domain. My domain is made up of 1, 2, 3 movies. And the 3 movies are The Avengers, Up, and The Simpsons. So therefore my domain would be The Avengers, Up, and The Simpsons. Okay, what would my range be? My range are only those output values that are actually linked to an input. So in this case here, 2015 is part of my range, 2009 is part of my range, and 2007 is part of my range. But 15, 14, 13, 11, 10, 9, 8 and 7, they're all my codomain. Okay, so therefore my range values would be 2015, 28 and 2007. Now, quick question. How would I describe the function that links the movies to the years? What question would I put? What link in terms of words would I put between the two? Well, I could simply say the function that links my domain to my range here is the function that links the movie to the year it was made. So Avengers, the function you could say was made in the year. Was made in year. So Avengers was made in the year 2015. Up was made in the year 2009. The Simpsons movie was made in the year 2007. Okay, so that's how we work out our domain, our function, our range, and our codomain. The following is not a function. I want you to look at this carefully and see what's wrong here that wasn't present in the other two sets. 1 goes to 2. 2 goes to 3. That's fine. And then look at 5. 5 is linked to 4, 5 is linked to 5, and 5 is linked to 7. Can you think of any function that allows one input to be spat out as 3 different values? If a function takes an input, does an operation on it, and then throws it out as a specific output, then there is never going to be a case where one input can give more than one answer. Okay, the way I like to think of it, the way our maths teacher told us when we were in school, is like this. The first circle represents people and the second circle represents countries. Okay, so person 1 goes to England, person 2 goes to Spain, person 5 tries to go to the Netherlands and France and Belgium at the same time. Impossible. One person cannot be in 3 different places at the same time. Therefore, one number cannot give 3 different solutions when it goes into a function. It simply doesn't happen. All right, so we have to watch out for repeating arrows that are coming from the domain to the range. And if you have any element in your domain that has more than one arrow to an output in your range, well, then you know that that is not a function. And this here is most definitely not a function. So there's 2 possibilities. First of all, every element in my domain can be linked individually, one-on-one, to a number in my codomain, which we would call your range. The second one could be where maybe 2 or 3 values in your domain could be linked to the same output. So for example, if I had a situation here where let's say 1 and 2 were linked to number 2. You ask yourself a question: can 2 people be in the same country? Can 1 and 2 both be in the same country, number 2? Yes, they can. So it's okay for me to have two input values linked to the same output, but it is never okay for one input to be linked to more than one output. Okay, so keep that in your mind as we're going forward, because it's going to help us to distinguish very quickly as to what is a function in maths and what is not a function. Okay, in order to exist as a function, one input can never have more than one output. So for every number you feed into this machine, it's going to spit out a unique solution, right? That's the key thing. It is possible, however, that two inputs could have the same output. Now, for example, if we take x squared, if I put in -2, what happens? -2 goes in, I square -2, plus 4 comes out, okay? If I take +2 and put it in, what happens? Exactly the same journey. So therefore, if I was to demonstrate this here, what I would say would be the following. You have your x values, you have your y values, -2 and 2 make up my domain, and 4 makes up my codomain. -2 is linked to 4, and 2 is linked to 4, and that's perfectly okay, because as I told you already, these two people can go to the same country. So therefore, as long as it makes sense in the everyday world, it makes perfect sense in mathematics. All right, keep that in your head. Okay, let's just take that, just an example of one function that allows two inputs to have the same output, and that's perfectly okay. But just remember that two inputs, one input can never have more than one output. So one input can't have 2 or 3 different answers. It can only have one answer. So here's another example. Now, let's see about this one. 1 is linked to D. So one person goes to Denmark. The second person goes to Canada. The third person also goes to Canada. Perfectly fine. 2 people going to the same country? Absolutely. And nobody goes to America. That's fine. So one person goes to Denmark, person 2 and 3, these 2 people here, they both go to Canada, nobody goes to Belgium, and nobody goes to America. Now, in mathematics, what do I say? My domain is what? 1, 2, 3. My range, which is the set of actual outputs, is only C and D. But my codomain is equal to what? A, B, C, and D, because they are all possible countries to visit. However, these 3 people have only decided to visit 2 of the 4, so the 2 that they visit happen to be the range, and the 4 possible visitation countries happen to be my codomain. All right. Okay. Now, I want you to pause this video. I want you to take a look at it, read the question, see if you can determine which one of these, as the question says, are functions. So have a look at A, B, C, D, E, and F. Have a look and see if you can identify which ones are functions, and then for those that are not functions, I want you to say why. So pause your video now. Okay, so hopefully at this stage you figured out on this one which one of A, B, C, D, E, and F are actual functions. Let's take part A. We've got 1 to 1 and 1 to 1. That's perfectly fine. So this element here is linked uniquely to this one, so that's okay. So there's a unique link there, and then we've got a unique link there, so that is a function. Okay, the next one, can these 2 people be in the same country? Absolutely. Is it okay not to visit a country? Perfect. And this person here decides to go, so that's most definitely a function. The next one, this person goes to this country. How can that person go to both Italy and Germany if it was Italy and Germany? How can this person be in 2 places at the one time? Can't. Not a function. And the reason why it's not a function is because the second element of my domain seems to be linked to 2 different outputs, not a function. Can these 2 people here go to this country? Yes. Can these 2 people here go to this? Yes, that's a function. Okay. However, here very quickly you can see that this person cannot split themselves in 2 and go to 2 different countries, not a function. And likewise here, that person there cannot split themselves. That's not a function. So it actually becomes quite easy once you understand that every element in your domain can only be linked to 1 output value in your range. Okay, that's it. So again, take a look at this one, have a look at the questions, see if you can come up with the answers, pause your video now, do 1, 2, and 3, and then when you're ready, unpause. Okay, so the following mapping is given: 1 to 8, 2 to 9, 3 to 10, 4 to 11. Now, before I read the questions, what do I already know? My domain values are 1, 2, 3, and 4. My codomain is 8, 9, 10, and 11. And my range is also 8, 9, 10, and 11 because all the values in my codomain are selected. So therefore, the codomain and the range in this case are exactly the same. Part 1. Is this mapping a function? And give a reason for your answer. Hopefully, you realize what a function is. A function occurs when every element in your domain is linked to one particular output. So is it a function? Absolutely is a function. Write out the domain and range in this mapping. Now, what I mean by that is to simply write down the elements in your domain. Your domain is 1, 2, 3, and 4. Your range is 8, 9, 10, and 11. And then it says, write an expression in terms of x for this mapping. In other words, what happened to 1, 2, 3, and 4 when they went through the function, which is represented by that arrow there, I'll put in an F here for the moment, and came out as 8, 9, 10, and 11. 1 comes out as 8. Why? Because we added on 7. Now, is that true for the rest of them? 2 plus 7 is 9, 3 plus 7 is 10, 4 plus 7 is 11. Yes. So therefore, here's what we would say. If you take the values of 1, 2, 3, and 4, and you want to get the values of 8, 9, 10, and 11, then the function that we're going to use is x plus 7. X, which always represents, by the way, your domain value. Okay, so when you're talking about where to place your domain value or what's happening to your domain value, you always refer to your domain value as your x values and your range values as your y values. Okay, so in this case, the function you're looking for here is the function x plus 7. Quite straightforward. Now, functions always have to have certain what we call notation, names or ways of writing them, and they're quite intricate, but again, practice will bring these to the fore very, very quickly. If we talk about a function, all right, as you go back to your juniors here to think about what a function is, the notation that you folks have already used were the notations that were given to you in terms of the groups of numbers that exist. So the most basic group of numbers we have, which are called the positive whole numbers, are your natural numbers, 1, 2, 3, 4, 5, etc. If you wish to include 0, then you're dealing with the set n0. Okay, we won't worry about that for a moment. So the natural numbers are simply numbers that are positive and whole numbers, up as far as, obviously, infinity. Okay, now, a word on infinity, by the way. Infinity is not a number. Infinity is an idea. We don't know what value it has. It's a symbol, okay? So it's never really used in mathematics in terms of calculations. It's only ever used to try and give an idea that we're moving towards something that's infinitely big. Okay, the next set of numbers we move to from there, we're back the way, through 0 back into the positive negative number, or the whole negative numbers. So your positives and your negative whole numbers are called the integers, all right? And that represents the set of numbers that comes from minus infinity all the way up, say, to -3, -2, -1, 0, 1, 2, 3, and then off again up to plus infinity. So in other words, what it takes in are all positive and negative whole numbers. Then we have z plus. Now this is new, because when they use this z plus, they're asking you only to look at the positive integers. So in one sense, we could say that z plus is exactly the same as n, because n are positive integers as well. Okay, so z plus is another way of saying, yeah, look, we're looking at the integers, but we're only looking at the positive aspect of these particular integers. Likewise, if we're using or, that's every number we can think of. Naturals, integers, quotients, irrationals, put them all together, you end up with the full set of numbers, which we call the real numbers. And again, if we only want to focus in on a certain part of that, you might look at, say, or plus, which are the positive rationals, starting at 0 and taking every natural, integer, quotient, and irrational number all the way up to infinity itself. Okay, and lastly then, Q, the letter capital Q we use for rational numbers, and Q plus again would be the positive rational numbers, which would be, now when we talk about rationals, we talk about numbers that can be represented as fractions. Okay, so Q plus would be plus a half, plus a quarter, plus 3/4, 7/10, whatever. Q, then all the rational numbers would take in the negative ones as well. but Q plus would just be on what we would call the right hand side of your number line from 0 up to infinity. All those numbers that can be represented as proper fractions, they would be under this Q plus. So with our notation in relation to our interval, now an interval is nothing more than a set of numbers, okay? We can't focus on the entire number line. So what we do instead is we focus on pieces of the number line. But there's always a problem. Say, for example, I'm looking at a number line that starts at A and goes to B, okay? There are numerous things we have to ask ourselves about the values, not only the ones that lie between A and B, but the values of A and B themselves, all right? And this is where we get different brackets coming in. Now, you haven't used different brackets before, but we're going to use them now. If in mathematics square brackets are used, square brackets will always tell me that I am using A and B and every number between, okay? So it's called a closed interval. And the reason why it's called a closed interval is it does not go beyond A and B. It starts at A, includes it, takes every number then up as far as B and includes B as well. So it's a closed interval in which A and B are included. What would happen if I had a number line where A and B were not included? So every value between A and B are to be included, but A and B themselves are to be excluded. How do I show that in terms of brackets? That's where we use the original, the ones that you're probably very used to, these round brackets, okay? And the round brackets simply dictate that we're dealing with all values between A and B with the exception of the values of A and B themselves, okay? And that's called an open interval. Then if we take the two and mix them together, you can see this one here, square bracket A, round bracket B, include A, do not include B. And finally, round bracket A, square bracket B, include B, but do not include A. Now, again, you'll see these being used as you go along, and you will have to use them yourselves. If you go back to when we were doing inequalities, there were times on your number line when you had to put a dot or a circle over numbers, okay? If you put a dot over the number, that would be a square bracket. If you put a circle over the number, that would be what we call a round bracket, or a proper name, a parentheses, okay? Parentheses. That's what the round brackets are, but don't worry about that. Round bracket, square bracket is perfectly fine by me. So dot represents square brackets on the number line, and a circle over the number where it's excluded would be now a round bracket. Okay. Consider the following. Now, f n n x 2x. So this is where the functions begin to take on a bit of life. The first thing I want to point out is every function must have a name. And the name of every function is nothing more than a small case letter of the alphabet. A, B, C, D, up as far as Z. Any of those letters are perfectly acceptable as the name of a function. Now, because the word function begins with F, it's a general trend, kind of like algebra, where they pick X for algebra as being the variable. There's a kind of a habit that we call it f of x, the function, all right? But we can use g, h, I, we can use a, b, c, x, y, z, it doesn't matter. But every function has to have a name, small case letter. Then what it tells me is where my domain values are coming from. Now in this case, all my domain values are coming from the set of natural numbers. 1, 2, 3, all positive whole numbers, okay? The function, which is always the arrow, is then going to change these domain values into range values, and my range also comes from the set of natural numbers, okay? So again, 1, 2, 3. So the numbers I'm going to put into this machine, this function, come from the set of naturals, and the numbers that are about to come out of this machine are also going to belong to the set of naturals, and that's all that means. So f is a function which we will put in natural numbers from my domain, and they will generate natural numbers in my range. Now the question obviously is, how will they do that? What's the actual mathematical operation? And that's what's at the end. X, as I told you already, again, is another way for your domain to be labelled. So they're your domain values, okay? And what happens to x through the function? It will become 2 times x. So just as an example, let's take 1, 2, and 3 as my domain. Now, from this here, what's going to happen? Each of these values are natural. they are going to be multiplied by 2 in order to generate the range. So that becomes 2, 4, and 6. And here's what I want you to notice. Those 3 belong to naturals in your domain. Those 3 belong to naturals in your range. And they are generated through the multiplication of 2, which is the actual function itself. All right, that's important to remember, the notation that's involved here. So the domain is n, as we said already. The codomain is n. The range is composed of even numbers of 2x. Now what that means is that when you take any value, and you'll notice when you multiply anything by 2, it becomes even. Okay, so 1 becomes 2, 2 becomes 4, 3 becomes 6, and so on. All functions, as I told you already, are named by a small case letter. So the function is going to take natural numbers from my domain. It's going to also generate numbers that are natural in my range, or in this case here, my codomain, if they're all the possible outputs, by taking the values from your domain and multiplying them by 2. All right. Now you'll see a lot of this in the pages of the book as we go through these questions, but you do need to be able to break them down. Consider the following function. What's this trying to tell me? Again, what's the name of the function? The name of the function is f. Okay. In my domain, where are the values going to come from? And the answer is the set of real numbers. Okay. Now, talk about my codomain next. My codomain are all possible solutions. Where will all my possible solutions lie? Notice that all my solutions will lie in only the positive aspect of the real numbers. So even though my domain takes all real numbers, positive and negative wholes, fractions, rationals and irrationals, the output will only have values that belong to the positive reals, everything after 0 up to infinity. Question is, how does it do that? And the arrow here links my domain to my codomain by generating values in my range that are e to the power of x. So again, if I was to take real numbers, and it doesn't matter what real numbers we could take -1, we could take 0 and 1. Let's just do that. -1, 0 and 1. What happens? Well, they are then placed in here as e to the -1, e to the 0, e to the 1. Now, question is this. Do each of those values belong to positive reals? Even though I've plugged in a negative real number, does it map to a positive real number? And the answer is yes. Because if you remember, e to the -1 is 1 over e. E to the 0, anything to 0 is 1, and e to the 1 is just e. So notice that they're all positive. So it holds true for every single item on that list. So name, domain, codomain, and this is how we generate the actual values of my range. So the domain is obviously f. Good. The codomain, what does that come from? Now the codomain comes from the set of positive reals. That's the second letter. Okay. The range is generated by the function e to the x. Okay. So input values and output values related through a function are usually paired. Now, we've had this before in junior cert. One of the greatest area where you use paired values were in coordinates. The 0.24, the point -17. They were the points that were generated by some type of function, algebraic function. All right. So normally if you're putting in a point and then you're doing something to it and you're getting a result, the input and the output are paired. And when they're paired, they form what we call coordinates. All right. So in this case here, we've got x and y. Now, what are the actual pairs? Well, the pairs, I'm going to use roundy brackets for this one, because that's what we're used to. So here we have 3 and 9, 1 and 1, 0 and 0, 4 to 16, -4 to 16. Now just pause there for a moment and think, is that possible? Is it okay for these two values to have the same output? And if you're not too sure, ask yourself a question. Could these two people go to the same country? Yes, so therefore it is a function. All right. Now what's happening? How does 3 become 9? How does 1 become 1? 0, 0, 4, 16 and -4, 16. Hopefully, if you think about it, what's the function? The function is x squared. All right, so 3 squared is 9, 1 squared is 1, 0 squared is 0, 4 squared is 16, minus 4 squared is 16, and so on. But what it does is it generates couples. All right, so we call these things here couples, and it generates them. Which means now that if functions generate couples, functions can be graphed. And that's the key thing. So functions generate couples, and couples can be graphed. Which means that we now see these functions generating couples that are going to end up on the xy plane. Okay. If functions generate couples, then coordinates are nothing more than a list of input-output couples, which are generated by a certain function. Now, that's extremely important. So the coordinates in any function are nothing more than a list of input and output couples. So in other words, if you have the point 4, 7, what that actually means is that 4 is your domain value and 7 is your range value. Meaning that 4 has gone through a function and come out as 7. Okay? And that's extremely important, because when we're using couples in coordinate geometry, we just slap them onto the xy axis. We don't think much about how they're related to one another. But the x value and the y value are always related by some type of function. So take the following quadratic function. Now I'm going to clear this screen here away, like that. And let's take the next one. Take this one here, all right? On this quadratic function, we've got 3 points. We've got the point minus 4, 0, 2, 0, and minus 1, 9. Now, what are they? Yes, they're couples. Yes, they're coordinates. Yes, I can plot them. But how are both values related to one another? And the answer is through some function. Now just take a look at the diagram. Can you see an algebraic function in there beside the graph that might be responsible for changing minus 4 into 0, or minus 1 into 9, or 2 into 0? Yeah, there it is. Y equals minus x squared minus 2x plus 8. And just to check that, let's throw in minus 4. And let's see what happens. Minus 4 squared is 16, but minus 4 squared becomes minus 16. Minus 2 times minus 4 is plus 8. And then we've got the final plus 8 down there. Minus 16 plus 8 is 0, which gives me the second part of my coordinate. So that's why it's extremely important to remember going forward in this chapter that coordinates contain the input and the output values that have gone through a certain function, or better still, are linked by a certain function. All right, so let's take a look at this. Page 128 example, it's a worked example in your book, 6.2. The diagram shows part of the graph of the function g, which is given by g of x. Now g, by the way, is the name of the function. Ax squared plus bx minus 2, where x is an element of real numbers. Now what that's telling me is that my domain values are coming from the set of reals. That's any number between minus infinity and plus infinity. Okay? But here's what I do know. That if this is the function, minus 2, 6, 1, 3 are linked to one another through that function. So in other words, minus 2 goes into the function and comes out as 6. And likewise here, 1 goes into the function and comes out as 3. So minus 2 goes in there, wherever the x is, and comes out as 6. And 1 goes into this function and comes out as 3. So once we understand that, we should be able to generate a statement of fact as to how this function links these domain and range values in both points. So it says find the values of a and b. Now again, go back to your algebra. Chapter 1, 2 and 3, book 1, extremely important. Whenever you're asked to get two values, a and b, please remember that the only way to get two values in algebra is by generating a pair of simultaneous equations. Okay, so let's just take the function on its own and let's take the 2 points that are there. So the function g is ax squared plus bx minus 2. So in terms of these 2 points here, what does that mean? Here's what it means. If I take minus 2 and put it into the function, it will come out as 6. And if I take minus 1 and put it into the function, it will come out as 3. Now, you might say to yourself, what function? This function here, this one. So let's do that. Let's put minus 2 in for x squared and see what happens. We're going to get a times minus 2 squared plus b times minus 2 is equal to 6. Okay. Minus 2 squared is 4. 4 times a is 4a. Minus 2b minus 2 is equal to 6. Now I told you before, usually when we're doing things in algebra, you keep the variables on one side and the constants on the other. So this gives me 4a minus 2b equals, let's get rid of that minus 2 by adding 2 to both sides, 8. There's equation 1. Now let's do the same thing with minus 1. Let's put minus 1 into the function where x is. We get a times minus 1 squared plus b times minus 1 minus 2 comes out as 3. So in other words, when I put minus 1 into both of these positions here and take away 2, the answer will be 3. That gives me a. Minus 1 squared is 1. 1 times a is a. Minus b. And again, minus 2 is equal to 3. But keep the variables together. Put the constants over the other side. A minus b is equal. How do I get rid of minus 2? Add 2 to both sides. 5. Now in this case, it's a very simple thing to do. All we've got to do is to line up these two equations if you want to, or what you could do is you could reorganize this one. If you reorganize that, here's what I know. A minus 5 is equal to b. Or put it another way if you wish. I don't mind which one you use, just to show you. You could also say that minus b is equal to 5 minus a, which means b is equal to a minus 5, just swapping all the signs around. And now that I've discovered what b is, what do? I bring it over here and put it in for b, which now gives me 4a minus 2 times the new value of b, which is a minus 5, is equal to 8. 4a minus 2a plus 10 is equal to 8. 4a minus 2a is 2a, and that's equal to 8 minus 10, which is minus 2. So a is minus 1. So there's a. And then over here, it tells me how to get b. So you bring the minus 1 over here, and then you say b is equal to minus 1 minus 5. B equals minus 6. And there's your two values. Now you can play that video again. You can go back over it and stop it and pause it and so on and watch what it's doing. But the key thing I want you to remember is this. Coordinates on a graph are a statement of how a domain value, the first one, x, is linked to a range value through a given function. So these couples that are being generated here have been generated by that particular function. Meaning minus 2 goes in for x here and gives out an answer of 6. Or in this case here, 1 goes in for x and gives out an answer of 3. Okay. So I'm going to leave you with these two. Question 9 and question 10 from page 132 of our textbook. I want you to do exactly the same thing as I just done in the previous question. Take a look at them. See if you can work out what the values of a and b are for both of them. And when we do that, we'll come back then to the next section of this function chapter.